The videos from week 2 outlined how to plot, describe, and predict motions in 2 dimensions using Newton's second law. We were introduced to the interaction between systems and their environment through forces, mainly highlighting that of gravity and drag force. The program tracker was used, and lectures detailed how to use the app in order to analyze and plot the motion of a moving object in a video uploaded into the program. We learned how to properly input parameters including length scales and frame rate to ensure the accuracy of tracker in describing the motion of the moving object. Additionally, the lectures described a method in which the future position of a moving object could be predicted using a small time frame and average velocity. Later on, the videos explained that this equation could be used in iteration by a computer to predict the position of an object over a period of time. The code used for this iteration and the prediction can be compared to observed motion graphed by a tracker and to describe the accuracy of this prediction and whether the chosen models were suitable for data collected and in modeling certain interactions. We also were exposed to the format in which lab reports would be posted and what contributed to a good lab report. I have never submitted a video lab report, but I'm used to student feedback since we had to present our findings in front of the class in my last physics class, so I have some experience in defending and explaining my findings. Finally, we were introduced to the idea of spring forces and Hooke's law. One thing from this week that I learned was how to use tracker to plot motion recorded in a video. Previously in physics classes, we used motion detectors which required the motion of an object to be towards or away from the detector. This program seems like an intuitive and easy way of measuring motions with the equipment we have at home. One thing that I already knew was Newton's second law and how to draw free body diagrams to help in the solving of kinematics problems. In my high school physics class, there was a large emphasis on this practice, so I feel comfortable with doing it. I also knew a lot about plotting data and about Hooke's law, which is something I also studied in high school physics. I really like the idea of using both tracker and a computer program to model motion. This two-step process allows for us to flesh out possible discrepancies in each process and determine why there are differences in the data collected from each. This seems more accurate than using one form over the other. In the soccer ball video, the differences in data were attributed to the ball rolling away from the camera a bit, which forces you to think about why some things may happen and how to account for these differences. I think that learning to work with a program might be a little bit difficult since the videos had to be in the correct format to measure from, but I think this will get easier with practice and in downloading apps that will help regulate frame rate and lighting. As a computer science major, I'm very excited to use coding in this class and iterative loops in order to model predictions in motion. In past physics classes, I've had a lot of experience in plotting information in Excel and retrieving data from motion detectors. In these labs, I've also had to determine why there are differences in the observed and plotted data, but a lot of these differences have been contributed to human error in measuring. However, I think that in using a video and plotting location in every screen of the video, this will help lower human error. I'm happy that we get to use computer programs to eliminate these aspects in our labs. The one topic that seems the most confusing to me is drag force because in the past I've had difficulty completing labs that have an emphasis on drag force. I found it hard to determine how drag force would change based on surface area, which is something I had to spend a lot of time practicing. Another topic that seems a bit hard to grasp is and practice is Hooke's law, and determining the movement of a spring based on length, spring constant, and forces acting on the spring. In the past, I have found the website PhET to be useful in simulating spring motion and easily changing parameters to see how the motion of the spring changes when these aspects are changed. I used the resources from the Week 2 module and found that the one from the textbook about net force was helpful since it outlined a few problems that included falling objects that were subject to the forces of gravity and drag force.